All right, guys, take a minute and try this bell work out, and we'll go over it. All right, for this bell work, we got the first equation, which is x equals 8. So I'll do this one in red. And for those of us that remember, hopefully we do, if it's an x equals situation, we're looking at a vertical line where x is 8. Okay, so all we're doing at this point really is looking for 8 on the x number line, which is the horizontal number line, right? You got the x-axis, you got the y-axis like this. So I just need to find out where 8 is on my x-axis, which would be 1, 2, 3 right there, okay? So that's going to give us a vertical line because on that line, x will be 8 everywhere, okay? So we end up with something like this. Now, you didn't really have to draw that line yet, but the nice thing about this is since x is 8, we know in the final answer for our ordered pair, we can just put right now x is 8. Because x has to be 8 to satisfy this equation, make it true, to be the solution there, okay? So that means it has to be 8 in this one as well, which means you could technically just solve that equation and not have to worry about graphing it. But we're going to graph it, okay? So this one, we're going to go and do in purple. And I can see right here, I'll start with the y-intercept, which is at, again, it's not just at 4, it's at 0, 4. Okay, so that's an ordered pair. And then the slope that they gave us is the coefficient of x, which is showing as negative 1/4. So I'm going to apply the negative to the numerator. What this means for us is that the rise is negative, which means we're going to go down 1, and then the run there is positive 4, so that'll be to the right 4. Okay, from that ordered pair that they gave us for the y-intercept. So let's go ahead and put that on there at 0, 4, which is here, and then I'll go down 1 to the right 4 here, and then down 1 to the right 4 here as well. You know, that's as far as I can go to the right. Of course, I'll have to go to the left as well. Left 4, up 1, and then left 4, up 1. Okay, so I can make my graph, and that's pretty much all I should need in order to solve this system. Okay, because we know that the red line is just telling us that x is 8, and we've already put that into the ordered pair, but all we need then is the y value that corresponds with it. Well, we can see it's right here, right? That's our solution. And what is that ordered pair? It looks like it's at 8, 2. Okay, so I'll just fill this in, 8, 2. That's it. So this one was nice because there was no need to change any of the equations into slope-intercept form. So it goes pretty good. Give us the slope and the y-intercept in that first equation. That's a vertical line. Remember, we've seen this on the classwork. If you see a y equals equation, then it's a horizontal line. You're just looking for the line where the y value is whatever the number is. All right, there's our objective. I can write repeated multiplication in exponent form, and also we should be able to expand exponent form. Then also, once we understand those two, we should know the difference between negative bases in parentheses and when they're not in parentheses. We'll go over that. Take a minute to copy this down, please. All right, just as a quick review for exponents, because you have seen these before, at least a little bit in 7th grade, but we forget everything from 7th grade, so here we go. In this expression, you got two values. You got a 5 and a 4, but notice the 4 is a little bit smaller in the, I guess I'd say that's the top right corner of the 5. The 5 is what we call a base, all right? This one right here, the 5, that's a base. And you're going to need to understand the vocabulary because I'm going to be using it quite a bit in this unit. And 4 is the exponent, also known as a power, okay? Now, mathematically, this is just a different way to communicate something. But it reads 5 to the power of 4. So the base to the power of the exponent is the way that will essentially always read whatever it is. For example, If we saw something else, like 7 to the power of 6, I guess, that'd be 7 to the power of 6 right there. That's how that reads. But the nice thing is we don't actually have to write the words out like this, 5 to the power of 4 or 7 to the power of 6, okay? So what do exponents do for us? Well, it's just a nice way to simplify multiplication. So we can go way back to elementary, and we hopefully understand that addition is just a simplified way to count. Multiplication is a simplified form of addition. So naturally, if we see repeated multiplication, mathematically we have a way to simplify that as well. Okay, so the base will tell you what number is being multiplied, and the exponent will tell you how many times it's being repeatedly multiplied, okay? So when you see something like this one right here, that reads 6 to the power of 4. Mathematically speaking, though, that gives us 4 6s, because that's the exponent, 4 6s, the base was 6, all being multiplied. Now, we don't have to evaluate that for now. But we do need to understand how to go between the two. So not only do we need to be able to take an exponential expression like this one, 6 to the power of 4, and change it into repeated multiplication, but we have to be able to change repeated multiplication into its more simplified form of exponential form, just like we saw on the objective, okay? So like this one, we can see that it's 7's being repeatedly multiplied, so you can just put that in right there with the 7, the base. The base is 7 here, and then since there's 5 of them, we make the exponent 5, 7 to the power of 5. So remember that mathematics is really just kind of a different way to show things with symbols. And, well, that's what this is right here. So if you just saw something like this without anything else, we need you to understand what these two symbols mean in this context, okay? And it's different. This does not mean, this is not 7 times 5, which is a very common mistake we see on tests and quizzes and even assignments, okay? That's not what this is. It's this one right there, okay? Now, I believe in 7th grade, maybe we did see a little bit of this in order of operations kind of stuff, but now all we're worried about for this lesson is, can you change repeated multiplication into exponential form? And can you take something that's in exponential form and change it into its repeated multiplication form as well? Like this one right here, right? What do we got? 8 times 8 times 8 times 8 times 8 times 8 times 8. So in exponential form, right? We know that it's just a bunch of 8's being multiplied. So I got a base that's 8, but it's repeated multiplication. So I know I'm looking for some form of exponential form, right? So I got kind of this little box that I got to fill in, and that's the exponent. Well, how many 8's were there? Well, we can count them. 1, 2, 3, 4, 5, 6, 7. It looks like 7 of them. So this ends up being 8 to the power of 7. Now in the assignment, you're going to have to be able to put this in. So here's how you're going to put it in, right? So first off, you'll type in 8, and this actually works pretty much the same way on the calculator. It's just the buttons look a little bit different. Okay, now you got to push these two together. So you're going to have to push Shift 6. Okay, now what that is, and once you guys get the computers, you'll see that it looks like this button right here. And it's the exact same button that's on the calculator. One button to the left of 7 and one button up. Okay, this right here, that symbol, that's the exponent. Well, I'll say button. It's called a caret, not that I think you care, but that's what it is. This is how you access exponents. Okay, so even on the assignment, you'll see that once you type this in, Shift 6, which has that little caret symbol right above the 6 on the keyboard, you'll see that the computer will change the cursor from this big base notation, and you'll see it actually change into its exponent notation. So, of course, on this one, you'll be in exponent mode then, so just push 7. And if by chance you needed to get out, you'd push over, I guess. But we don't need to on this one. All you'd need to do at that point is just push Enter. Okay? And it'll tell you that this would be correct. Okay, so if you type this in, you'd see pretty much something that looks like this, and you'd get the answer correct. So yeah, this, the program that we're using for the assignments, it does work this way, and you have to be able to know how to access the exponent mode in order to put those in. And this is one way to do it. I think if you click on the box to put in your answer, it may give you some options, but I don't remember if it does. So Shift 6 will work though. How about this one? So this one, we see -5s in parentheses. Okay, so that shouldn't be too difficult to see here, that we should know that the base here is -5, but see how it's all of these are in parentheses here? So my -5 there, I'm gonna keep it in parentheses as well. Okay, which means again, all I'm looking to do is insert the exponent. Okay, so how many -5s is that? 1, 2, 3, 4. So I end up with -5 in parentheses to the power 4. And the parentheses here are crucial, because without them, it changes the answer for us, which we will see later on in this classwork. Now this means also in Canvas, when you guys are entering your answers, you need to type in the parentheses here as well. Okay, so that's Shift 9 and Shift 0, just in case you didn't know, but they're there. On this one, we got a lot of multiplication, but you can see that there's a bunch of 6s being multiplied, then suddenly it changes to 7s. That's okay. All right, so we're gonna keep those separated. We got a base 6 and also a base 7. So there's no need to combine these or multiply them into 42s. I mean, you could, it's just, that's not really what we're looking for on this, okay? So I've got 2 bases. What are the exponents? Well, just got to figure out how many 6s there are. 1, 2, 3, 4, 5, 6, 7, 8 of those 6s. So I end up with 6 to the power of 8. And then how many of the 7s are there? 1, 2, 3, 4. So I end up with 7 to the power of 4. I believe on the assignment you should put some multiplication in between there. But I don't think that it's necessary as well. So you could try it without and then try it with it, just in case it gives you no credit for that, okay? So how would you enter this into the computer? Well, you're gonna type in your 6 first, right? So just type in 6. Now you need to access the exponent mode, right? So you're gonna push that Shift 6 stuff. Shift 6, which again it's that caret exponent symbol. Then you'll type in your exponent, 8. Now that'll show 6 to the power of 8, but now we need 7 to the power of 4. So I would push the multiplication symbol, which is, I guess it's Shift 8, that's multiplying. It's an asterisk, but either way. Okay. Oh, actually before that, I made a mistake there. We still need that Shift 8, but we gotta go back. Because if you're still in exponent mode, then it'll keep you in exponent mode. You gotta be able to get out of exponent mode. Just push to the right. The right arrow, or to the right. I guess you could click on it as well. That would work. This function right here, pushing to the right, that's gonna get you out of exponent mode there. Okay, now you're gonna push Shift 8 so you can put in your multiplication. Okay, so if you don't push this symbol, you'll see that you're just typing more things into your exponent mode. We need to get out of exponent mode with this button right here. And the calculator is gonna work the same way when we need to evaluate these. So now that I got my multiplication, I'm ready for my next exponent, which is 7 to the power of 4, right? So I'm going to type in my base 7. And then once again, I need my exponent mode here. So Shift 6. And then I need my exponent, 4. And from here, again, you can get out of that exponent mode again if you'd like and push to the right, or you can just push Enter. Either way, and it'll give you full credit right there. But you'll see that it should look almost essentially exactly like this, just with a little asterisk in between here. I understand that, I guess, just typing those into the computer, at least just when we're getting used to them, may take a little bit longer than actually doing the problem, but it's a nice way to to be able to get these into a computer, okay? So, write the following in expanded form. So on this one, I can see that my base here, that's negative 9. But it's not just negative 9, right? It's a negative 9 that's also in parentheses. So I'm going to have a bunch of negative 9s, but how many of them am I going to have? I'm going to have 4 of them, okay? Because the exponent here, yeah, it's 4, right? So I need 4 of those. Let's go and put down 4 of those. Try to use some technology. This one right here. All right? Now, when you need to enter this into the assignment, really all you need is just to make sure that you're putting parentheses around these. If you wanted to put the asterisk or the multiplication between these, you could. But you don't necessarily need to. We've talked about this before. Multiplication is a symbol that doesn't always have to be shown. So if you want to show it, that's fine. The computer will accept that. If you don't put it in there, it's fine. The computer will accept that too. All right? All right, let's write this one in expanded form. We just got that negative out in front. Now, about this, it's important to remember right here that the negative is not in the parentheses, which means that really what you have, I'm going to rewrite this with a little space there. It's negative, and then parentheses 2 to the power of 5. And what you don't want to do on this one is to take that and then show it 5 times, right? So there's 1, 2, you don't want this. And I know those look like subtractions, but there's a point to all this, okay? So we have all this, and 1 more, right? Because we need 5 of them. That's not what we want. And again, whether you even have the multiplication between these, that's not what we want either. And if you do it like this, then what you've essentially done is gone out of the order of operations. So we can't just do that, okay? So here's what, again, this is what you should not do. This stuff. So what should we do? Well, this is what we should do. See if I can get in there. Is we need to do this by the order of operations. So remember, the order of operations is parentheses first, right? Well, we got a set of parentheses. It's just there's nothing to do on the inside. So what's after parentheses? Now we have exponents. That's where we get this power of 5 right there. So it's not the negative that's to the power of 5. It's only the 2. So I got to take that 2, and I need to multiply it by itself 5 times, right? So there's 1. I'll give myself a little bit more space there. There's 1. There's 2. Need 3 more, right? And 1 more. There we go. 5 of these. Okay, but then we would apply that negative out to the front. So the negative that's out there in the front, it just stays out there in the front. Okay, so as it turns out, this one is actually our final answer on this one in expanded form. Again, it's not this one, okay? Well, why is that negative not duplicated 5 times with the multiplication? It's because if you were to look at that expression, let's look at the original. Negative with 2 to the power of 5 like this. There's a phantom 1 right there, just like we've seen a lot of before, and that's being multiplied. That's why in the order of operations, you have to do 2 to the power of 5 first. So that's why we did these 5 first. And then, again, there's the 1 there, it's just a phantom 1. You just can't see it. It's lurking in the shadows watching. Okay. This one I chose to show, just so we can understand that it's a order of operations problem. Take your 2 to the power of 5 first, and then apply that negative. Is it possible to have fractions that have repeated multiplication? Sure. Again, we're not asking you to evaluate this. We don't want the actual solution here. All we want you to do is change this into its expanded form. So that 1/5, it's already in parentheses. I'm just going to keep it that way. That's going to make that nice and convenient. And so I need 3 of them, right? 1, 2, and 1 more. There we go, 1, 2, 3 of them. So once again, we have our base on this one, the 1/5, and there's 3 of them. Okay, so how many did we get? 1, 2, 3. There's our answer. All right, write this one in expanded form. On this one, we got 88 to the power of 1. And, well, how many... This is not meant to be a trick question, you guys. It's just 88, right? So, in fact, let's go and keep it in parentheses even. So our base is 88. How many 88s do we got? One of them. That's done. In fact, I think on the assignment, you don't even need the parentheses if you don't want to put it there. All right, our last objective is to know the difference between bases. Now, we've seen something kind of like that second one, right? With the -2 and parentheses to the power 4. Let's look at that one first then. Okay, so this one, if I were to expand it, and I'm going to solve these ones, even though on the assignment you don't actually have to solve anything, right? So I'm going to take this, and I'm just going to duplicate it right here, but I need 4 of them, right? So I need 1, 2, there's the second one, and then I'll just duplicate both of them. That's all right. 4 of them, okay? Now, if we were to solve this, which we would, which is going to help us to understand what is going on here, then we would say, I would first figure out if the answer is positive or negative, right? So on this one, you got a negative, a negative, a negative, and a negative. That's 4 negatives. And 4 is even, which makes our answer a positive value, okay? And then we know 2 times 2 is 4, times 2 is 8, times 2 is 16. So we end up with positive 16 on this one, okay? Now, we understand how the parentheses work. We've seen a problem like that already, expanding an exponential form with the negative base. But up here at the top, it's not that the base itself is negative, okay? And this goes back to what we saw with, well, the 2 would be in parentheses right here. We have to do this in the order of operation. So really what you end up with is, you got a -2 to the power 4, but there's no parentheses, which indicates what you really have is -1 times 2 to the power 4. So if I were to expand this, you'd have to use the order of operations with 2 to the power of 4. So I have a 2, but I need 4 of them being multiplied, right? So 2 times 2 times 2 times 2. There's 4 2's multiplied. But then we would keep that -1 out there in the front. All right, now, if you went this far, you'd see, hopefully, that in this case, there's only 1 negative being multiplied. And the way we did that in this class is we see if there's an odd number of negatives, your answer is a negative. And then you do your multiplication of 2 times 2 is 4, times 2 is 8, times 2 is 16. This one ends up being -16 because there was no parentheses with the base 2. Okay, so it really ends up being, just by order of operation, you have to do that exponent first, and then you can apply the multiplication right there. So while these look very similar as 16s, one's negative and one's positive. That makes them very different. All right? And you need to understand the difference between these two moving forward in this unit, because we're going to see some of this stuff in the future, just like we did today, changing something like this one into exponent form, and then understanding how this one would be shown in exponent or in expanded form, or even how you would change this one back into exponent form. So we went through all 3 objectives. I can write repeated multiplication in exponent form. That was our first part. And then we need to be able to expand exponent form. I think that was our second part. And then that last slide there is just knowing the difference between negative bases in parentheses, and also if they're not in parentheses.